everyone. So today we're going to move on to a new topic. So we will have introduction to probability for week number 5 of the fourth quarter. So here in this lesson we're going to learn about experiment, outcome, sample space, and event. Before we proceed, here is a short announcement. So on May 24, 2022, we will have our third red letter day. So because that red letter day is for the third quarter. So see you there. Our objectives for this lesson are define probability, understand the basic concept of probability. So here we will identify the terms found in our title. We have the experiment, outcome, sample space, and event. And for the last part, we will solve problems involving probability. Okay. So first of all, let us consider this scenario. Okay, your mother gave you 10 identical looking gram balls. She said that 5 are chocolate filled and 5 have marshmallows at the center. What is the probability that you can get your favorite chocolate-filled gram ball after picking one out of the 10 balls? So let us analyze the problem. So what do we have? We have 10 identical looking gram balls, meaning we don't know which is which. So there's no way for us to determine which ones have marshmallows at the center or which ones are chocolate filled. Okay, so we are hoping to get one of these 5 chocolate-filled gram balls because that is our favorite. Okay, so let's put that here on our board. Okay, so 5, no? Because we are hoping to get one of these 5 chocolate-filled balls. Okay, and our denominator is 10 because we have a total number of 10 gram balls. Okay, so if we reduce this to lowest term, we will have 5 over 10 is equivalent to 1/2. Or we could say that 50%, we have 50% chance or we have 50% probability of getting what we want. Okay, perhaps you've also heard of the term 50-50. So we have an even chance of getting a chocolate-filled gram ball. So what if we change the situation? What if we only have 2 bowls with marshmallows in it and 8 of them are chocolate filled? So now we still have 10 at our denominator because we still have the same total number of gram balls, but this time our numerator will be 8 because we have 8 chocolate filled gram balls, which is what we are considering of getting, we are hoping to get. Okay, so if we reduce that to lowest term, we have 4 over 5, or if we convert it to percent, we have 80%. A big 80% chance of getting the gram ball that we want, or our favorite flavor or your favorite kind. Okay, so based on this example, let us define probability. Probabilities are associated with experiments where the outcome is not known in advance or cannot be predicted. That is why, just like in science, right, we still need to conduct the experiments even if we have an idea what are the possible outcomes, because we don't know in advance or we cannot predict what the actual outcome would be. Okay, we just have an idea, or we have, well, we could list down the possible outcomes, but unless we perform the experiment, that's the only time that we will know the actual outcome. Okay, probability can be expressed as a fraction. We did that as a decimal or a percent. Okay, so here, let's take a look at this scenario or of this illustration so that we can have a clearer view of probability. So just like in our example or the Graham Ball scenario, okay, if we're going to toss a coin, we only have two possibilities. It's either we get a head or a tail. So if we want to get a head as a result, okay, we have an even chance, okay, because there are only two possible outcomes. It's either head or tail. So we have an even chance of getting that, or even probability to get that result. But what if we roll two dice? Okay, so the highest possible outcome of rolling a single die is 6. So if we have two dice, so that's 6 plus 6, we have 12. But if we want to have a result of 14, so the probability of that is impossible, because the highest possible number or total is only 12 when we roll two dice. So rolling a 14 would be impossible. So what if we want to know the probability if the sun will rise tomorrow? Now, in this scenario, the probability or the chances are certain. Okay, so you might argue that, Mom, sometimes we cannot see the sun. Okay, it's simply hiding behind the clouds, or if it's raining, of course, we cannot actually see the sun, but the sun is there, and the sun will rise each and every day. Okay, so the probability of that happening is certain. Okay, so if we talk about anything in between, for example, just like in the case of the Grambles, when we have 8 chocolate filled ones, so we have 80% chance. Then if it's between an even chance and being certain, so it's more likely to happen. But it's if it's between impossible and getting an even chance of getting that event, then that's less likely to happen. For example, you want to court a girl, but that girl is in love with somebody else. So you have a less likely or a small chance of getting a yes as an answer. Okay? So now let's define the terms. Experiment. Experiment is any process or situational activity that involves chance. Okay? Just like in science, the result cannot be predicted with certainty unless you actually perform the experiment. And then we talk about outcome. Outcome is the result of a single trial of an experiment. So if we perform the experiment a number of times, then we will have different outcomes. Okay? So in our example, in flipping a coin, the outcome may be a head or a tail. So if we're going to roll a die, it could be any number from 1 to 6. That is our outcome. Okay? The sample space. So sample space is simply the set of all the possible outcomes. So all we have to do is list down all the possible outcomes. So we write it down. We denote it by a capital S or a big letter S. And if we want to write down the total number of the sample space, then we denote it by N quantity S. So in our example, in flipping a coin, we have 2. The number of possible outcomes is 2. And then if we write it down, just like in writing a set, so it could be H and T, head or tail. Okay, in rolling a die, so we write it all 1 to 6. So 1, 2, 3, 4, 5, and 6. That is the set of the possible outcomes or our sample space. So the number is 6. Okay? A sample point is simply just one of the possible outcomes. So you could take any of the possible outcomes, and that will be our sample point. Okay? So here again, in our example, we already explained flipping a coin and rolling a die. But in the first one, we have flipping 2 coins. So instead of just considering a head or a tail, we have to consider the outcome for each of the coins. So when we flip 2 coins, it's either 2 heads, or the first coin is head and the second coin is a tail, or the first coin is a tail and the second one is a head, or both of them are tails. And then we simply get one of those outcomes to come up with a sample point. Okay, the rolling a die, okay, we already have that example. How about in drawing a card from a deck of 52? Okay, so here we showed all of them, all of the possible cards. Okay, and then the sample point, we need to be specific. So we cannot say simply a king because we have 4 kings on our deck of card. Or we simply cannot say hearts because we have 13 hearts on our deck of cards. So when we identify a sample point, we need to be specific. So in this example, king of hearts. So we could choose queen of spades. Okay, that's just an example. Okay. Next term, event. So event is a subset. So if we have a sample space, we will get part of that, a subset, okay, of possible outcomes satisfying a given condition. So this time around, there's a condition, okay, and so we could list down the possible outcomes that will satisfy that condition. Okay, so for example, our condition is to get 3 tails when flipping a coin thrice, or choosing a king from a deck of cards, so any of those 4 kings, or getting an odd number when rolling a die. So again, the difference here is we have a certain condition. Okay, and then we list down the possible outcomes that will satisfy that condition. Okay? So here, this is exactly what you're going to do in your learning task. I will not show you the answer in this video because I would like you to try to answer that learning task, but I will just explain the problem. So the given is this. We have numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 that are written separately in pieces of paper. So just like here in the illustration. Then they are folded and placed inside the box. And then we're going to get one piece of paper randomly. Okay, so now what is being asked is the event. What is the event of getting, or here are the conditions. So if the condition is, what is the event of getting at least 3? Okay, so what you have to do is you have to list down or write the set of outcomes, okay, possible outcomes that will satisfy this event. Or what event will satisfy the given that a number that we're going to pick is between 4 and 7. So again, the answer here, okay, will depend on the given situation, okay, and then you have to list it down, okay. So the answer here is a set. What are the possible outcomes that will satisfy the condition, the given condition? Okay. So if you for before the before the questions, okay, let's sum it up. Probability measures and quantifies how likely an event of an experiment with unpredictable outcomes will happen. So the value is between 0 and 1 inclusive. So 0 is included. Okay, so if the probability that something will not happen, then it is equal to 0. But if the probability of an event is certain, then the probability is equal to 1. Anything in between, okay, can be represented in fraction form, okay, or in percent or in decimal. Okay? So again, thank you for tuning in to this lesson. There will be follow-up video clips that will help you and guide you in answering the learning tasks. If you have further questions or additional questions, just send us a message and we will get back to you. Again, thank you very much, everyone. Take care. Bye-bye.